Hello everyone and welcome to another NuclearCraft video. This time it's the CraftTweaker tutorial. I did one of these before, but the way that CraftTweaker support works has changed quite a lot. All of your old methods should work, but there is basically a whole new system that's in place that is basically recommended. It has a few more useful pieces to it, which allows you to make some slightly more complicated recipes. So I'm just going to take you through them now. Hopefully this won't be too long. But we have to go through item recipes, fluid, ingredients, and so forth. We won't go through every single machine, because the whole point of this new system is that it's meant to be like pretty uniform for all different types of recipes, whether it be machine or fission or fusion. But I've basically just got these machines here to test out whatever recipes we add to the game. So obviously the thing with CraftTweaker now is that you have to sort of reload your whole game, so this might take a little while to record, but hopefully it will be alright in the video. So let's just get started. So the way I'm going to do this is, as you can see, I've not got a full window here. I'm just going to go into this Notepad++ script here. This is just a script file in my instance scripts folder. This is a great Notepad sort of variety, by the way. Notepad++, highly recommended, it's free. But basically, we're going to add some recipes. So I've got this empty script here. I might as well just close down the game, there's no point of having it open at the moment. And I've also got this CraftTweaker.txt file. Now, you can actually find this in the GitHub, NuclearCraft GitHub sort of repository. But I'll also put a link in the description to it. Basically, this explains everything you need to know. But this is a video just to sort of go through it quickly. If you want to really know how to get, if you want to get used to this very quickly, I'd just read all this stuff. The basic idea is that there is ways to add recipes that involve just a block of information involving ingredients and the amount of said ingredient and maybe some chance stuff in there as well that's like says, okay, sometimes produce 3 coal, sometimes produce 1 coal, whatever. So we're just going to go through exactly how that works. So we'll start with the most basic, which is the manufactory, which is just 1 item input and 1 item output. I'm literally just going to copy this thing here and I'm just going to paste it into this script. So all of the methods have this sort of name, the mods.nuclearcraft and the name of the machine, and then add recipe. Now, usually in CraftTweaker, you'd then have a bracket, open bracket, and then you'd write all your recipe stuff, and then you have a closed bracket. But as you can see with NuclearCraft, you also need this square bracket, and the reason that is because in NuclearCraft, the way that recipes are sort of processed in the code is it basically takes an array of information, and to specify an array in ZenScript, which is what CraftTweaker uses, you need to have these square brackets as well. So let's just start with a really basic recipe. Let's go and get ourselves, the way this works is that you basically type your stuff in here with these triangle brackets, and I'm going to just make a simple recipe that takes Minecraft, let's say cobblestone, let's just say stone, and we're going to take Minecraft stone, and we're going to take 3 of those stone, and we're going to produce a completely random recipe, and we're going to produce a Minecraft, what should we produce? Minecraft, oops, let's make some wool, and let's make a certain colour of wool. I think the colour 1 might be orange wool, and let's make like 2 of them. And we have here some optional stuff that we can add on the end. So anything in curly brackets in the NuclearCraft sort of tutorial, anything in curly brackets is optional, but you have to make sure it's in order. So if you're going to add a power multiplier, you also have to make sure you have a time multiplier before it. If you're going to add some process radiation, which basically means how much radiation the machine's going to produce when the machine's running. We'll get to what radiation is in another tutorial. I haven't made that one yet, but radiation's a new added thing in NuclearCraft. You need to first of all put a time multiplier and a power multiplier. So I'm going to forget about the radiation for now, because we haven't really done anything with that yet. Get rid of these curly brackets, you really don't want them, that will break the code. And I'm going to put a time multiplier in, so it's a double, which basically just means a decimal. I'm going to put a time multiplier of, let's put, just to make it obvious that it's a bit quicker, let's put 0.1, so it's a very quick recipe. And it's going to have a power multiplier of 5, let's say. So we're going to be 10 times quicker, but 5 times the amount of power. Oh, and one thing I just discovered the hard way by finding out this didn't work, you've got to make sure that you put a .0 at the end here if it's going to be an integer, because if you just put 5, CraftTweaker will read that as an integer rather than a double, and that means that it won't work properly. So you need to make sure that this is 5.0 or whatever 0.0 if you're going to use an integer argument here in the extras when it needs a double. When it needs a decimal, you need to make sure that you make it very clear that that's the case. Otherwise, it won't be read properly. So now it should work. It didn't work the first time I tried this because of that. So let's get this loaded up. Okay, so our world has loaded back up again. Now, by the way, when I said it didn't work last time, what I actually mean is that the power setting, the five times power setting didn't work. The rest of it did carry through. This is the power didn't, but now the power should. So if we look at the uses for stone, we can see here in the manufactory, 3 stone, go to 2 orange wool, and as you can see, if we compare it to the speeds of other recipes, it's much faster, which is because we set the speed to 10 times the usual. So there we go, 3 to 2 orange wool, and if we head over to the manufactory, now you can see here that, don't worry about the actual numbers here because I've changed up in the configs just to make things a bit quicker, but you can see the normal process time here is 64 RF per tick. So we hope to see a process time of process power of 320 RF per tick when we put a load of stone in. As you can see, that's exactly what happens. And because it's a very quick recipe, there we go, orange wool, you get a load of it. So that recipe works. Beautiful. So now, what we can do is we can start playing around with some slightly more complicated stuff. First complication, of course, we can close this now. First complication is to use the OR dictionary. So the OR dictionary, for those who don't know, it's basically a way of mods being able to say that certain items are basically equal to each other. So if loads of mods add different types of copper, then they can all add their copper ingots to the copper ingot OR dictionary, and basically all the copper ingots will be used in all the recipes, as you might expect. So, I'm in the wrong place here. I'm meant to be in here. So this time let's try an isotope separator recipe. This needs 1 input and 2 outputs. So let's just copy this. Of course, the fact it's an isotope separator doesn't mean anything at all. It's just called that. We can add whatever recipes we want. This time I'm going to make a time multiplier of, let's say, 5. And let's add a power multiplier of, let's do quarter. And let's add no radiation. Remember, get rid of those curly brackets because you don't want them. That will make it not work. Item input. Now this time I'm going to put an OR dictionary entry in. I'm going to put OR copper. Ingot copper. Ingot copper. And I'm going to have, let's say, 5 of them. And that's going to go to an OR output of a block of tin. Just 1 of them. And I'm also going to have an OR output of, let's say, ingot bronze times 2. Okay, so what this will do is it will basically add all copper as a valid input for this recipe, but what it will then do is it will then take the prioritized entry of block tin. So the way you set that is in the NuclearCraft configs. There's a config option to basically order the mod's priority in the OR dictionary. So if you want all the thermal foundation stuff to come up first, you put that as a top priority mod. So the tin block from thermal foundation will be the first thing it looks for, and if it can't find that, it will go to the second priority, etc., etc. So I don't actually think I have thermal foundation installed. I have mechanism installed, so it might take that tin block. And then bronze ingots, I'm not sure mechanism has bronze ingots, so it might just take the bronze ingots from NuclearCraft. We'll just have to see. It all depends on what the config options are and what mods we have installed. But there we go, that's the recipe. So let's load up the game and see if it works. Boom. Right, so let's have a look at these isotope separator recipes. Oh, what's going on here? Isotope separator, show recipes. Now we head to the back here, we can see a very slow recipe. We set the time, what do we set the time to? 5.0, so very slow, but also the power should be down. But you can see here that it got the tin block from NuclearCraft, and it got the bronze ingot from NuclearCraft. But you can see here that it must be that mechanism doesn't have a tin block or something, or maybe NuclearCraft's prioritized. But you can see here that any copper ingots should be a valid input here. So let's go to the isotope separator. So this should mean that because we put the process power to quarter, that means it should be an 8 RF per tick recipe. Let's go and get some copper ingots then. So there's a bunch of copper ingots we can use. We can use the mechanism one. You can see here it goes to 8 RF per tick. Let's feed this through. And we should get tin block and bronze alloy. And of course you can use a different copper ingot from another mod. Works in exactly the same way. Let's get a few more speed upgrades in there, just speed this up. There we go, tin block, two bronze alloy. So there we go, OR dictionary. That's basically the way that works. If you add an OR dictionary input, then it will allow any of those in the OR dictionary to be a valid input, and for the output it will just choose the prioritized stack that's in that OR dictionary entry. Okay, next thing is fluids. So some of the recipes in NuclearCraft involve fluids. So if we head over to this CraftTweaker thing, let's have a look at the first one that involves fluids. The first one that involves fluids is the infuser. Okay, so the infuser takes an item and infuses it with a liquid. So let's get another bit here. So the infuser, let's do an item input. Let's do a mix this time. So let's have an input of, I don't know, let's do Minecraft dirt. Let's have 7 dirt and a fluid input. Now the way you do fluids, I believe, is liquid, and then you put the liquid. So let's just put lava, and then you put the number of millibuckets. So let's do 500 millibuckets, and then an item output of let's do an ore output this time, ore ingot iron. You get 1 iron ingot out of this, and this time we'll just not put any extra multipliers on it. If you just don't put any, then it will just use the defaults. So that's our recipe. Let's load it up, and let's go and have a look at this infuser recipe. Here's infuser recipes. We head to the back here. There we go. There's our recipes. We've got 7 dirt, 500 lava, iron ingot or ingot iron. But that's the only entry, so we just get an iron ingot out of it. And of course, we could just do this recipe. So let's get ourselves some dirt. Oops. Let's get some dirt, and let's get some lava. So you can now just put some lava in like that, and you can see there's our recipe just completed. So because I put a whole bucket worth in, it did 2 lots of the recipe because it's 500 mils, and there we go, iron ingot from dirt and lava. Fantastic. So that's how you do fluids. Fluids pretty simple. Works a little bit like the OR dictionary. Okay, so the next thing, if we look in this list of things that we can do, is we can do item inputs, fluid inputs, but we can also do, as you can see here, chance inputs. Oh, hang on, what's here? So chance item stacks and chance fluid stacks. So there's a couple of different options here. As you can see, that for a chance item stack, so for items or for OR dictionary inputs or outputs, we can just add a percentage on the end, or we can add a percentage and then a minimum stack size. So the way this works, we'll do 2 lots of it. Let's close this. The way this works is we can have, let's just actually take this example here. So this example here is a Minecraft coal times 2, so 2 lots of coal, but only a 25% chance of being actually created in the recipe. Now, of course, it doesn't actually make any sense to do this in the inputs and in the inputs. So if you put chance inputs, I think the recipe will break. I'm not actually sure. It will either break or it will just ignore the chance stuff. I just don't recommend putting any input stuff with chance in. But obviously for outputs, chance makes perfect sense. It just means that you sometimes get the items, sometimes you don't. So I'm going to make a recipe. Let's see what we should do here. Let's do a rock crush recipe, because the rock crusher has quite a lot of outputs that we can make use of. Where is that? Rock crusher is, where is it? Here it is. So let's get this thing. Rock crusher script. Boom. Okay, so we have 1 input and 3 outputs. Let's just make our input really simple. Let's just make it stone again. Minecraft stone. And let's just do 4 of them. And now we're going to have some chance outputs. So you can mix and match chance with non-chance, as you might expect. And if we zoom back up here again, this is the way you sort of do it. So a basic chance stack is just the stack and the percentage chance that it's generated. So let's do that first of all. Coal times 2 times 25. So let's put that in there. So that means 25% of the chance, 25% of the time, I will get 2 coal from this recipe. Okay, next what we can do, if we go back over here, is we can also add a minimum stack size onto here. So a minimum stack size just basically means, so for example here, what it will say is when the glowstone output is calculated, it will produce a minimum of 2 glowstone, but there's also a chance it will produce 3 glowstone. It sort of works like a binomial, the binomial distribution, if you're used to that. So the way the binomial distribution works is that you have a certain chance of success on each flip of the coin. So the flip of the coin has a certain percentage. That will be this percentage here. So there's a 60% chance in this case that will be heads. And every time you flip heads, it will generate a glowstone. But here you're going to fix a minimum of 2 glowstones. So what this will do is, because the minimum is 2 and the maximum is 3, it will flip 1 coin, and 60% of the time you'll get 3 glowstone, 40% of the time you'll get 2 glowstone. If I change this up, if I just copy this over and change up a little bit. So, as you can see here, I don't actually have to put any more sort of brackets or anything. It just goes all in line like this. It will work it out itself in the code. If I was to do something like, I don't know, 5 glowstone and then like a 30% chance, what will happen here is, because there's a gap of 3 from the minimum to the maximum, there will be 3 coin tosses, and each of those coin tosses has a 30% chance of success, and if there is a success, it will add 1 to the stack from 2. So that basically means that, well, actually the percentages are quite nasty to work out, but most of the time you'll be producing like 2 or 3 glowstone, and then more rare is 4, and then very rare is 5, because getting 3 successive 30% chances in a row is obviously quite low. But there we go, that's our recipe. So maximum of 5, low of 2. So finally I'm just going to put a normal output here. I'm going to put ore. Let's just do ingot gold. Ingot gold. Okay. And let's do a time multiplier of 2.0 and a power multiplier of, I don't know, 0.77. Sure. Now, just while my game is loading, I'll try to explain in a bit more detail, now that I remember, why these have to be doubles and they can't be just integers. As you can see here, when you actually put a chance stack into this recipe list, you'll have integers coming after the ingredients. And of course, if I was to allow the power and time multipliers to also be integers, then sometimes these numbers might get mixed up with these. So say if I wanted a chance gold stack on the end here, then I'd have to put some extra numbers, and obviously those could get mixed up with the multipliers if there wasn't a distinct difference between the type of number that was being accepted. So that's the reason that I have to limit what I can read as the multipliers to doubles. So that's a bit more of a detailed explanation of why I have to do that. Okay, so here we are. Let's go and have a look at the Rock Crusher recipes. You can see here on the end we have our recipe. Now, as you can see, it's showing that 4 stone go to these outputs. Now, the way this works in JEI, it's a bit different in JEI. So in JEI, what I've done is there's a config option to allow showing a empty stack here if there's a possibility that it will generate an empty stack. Otherwise, it will show a minimum of 1. The reason is because it actually looks pretty nasty when you see 0 stacks and you see the coal and the different ingredients flashing in and out. So that's the reason that that's a config option. Of course, you can turn that off, and so you can see the whole 0, 1, 2 coal in here. If you look here, you can actually see that some of these default Rock Crush recipes actually use chance stacks here, the Crush Rhodochrosite and all these different Crush gems. They have chance recipes. But you can see here that the glowstone is showing exactly what we expected, anywhere between 2 and 5. And the coal, remember, because of that JEI option in the configs, is showing 1 to 2, but actually is 0 to 2. And obviously this gold on the end is what we expected. So let's actually put some stone in there. And let's see what the recipe is here. So 64 RF per tick. Remember here we put that it was going to be 0.77 power, so that's going to be some weird number. Yeah, some weird number. And you can see here that we got 1 coal, 0 coal that time, 0 coal again, 0 coal, 1 coal, 0 coal again. The reason coal is being so rare, of course, is because what's happening here is that the game is doing 2 25% coin flips. So even the chance of just getting 1 coal is very low. The chance of getting 2 is very, very low. So out of all that stone there, that was 16 lots of recipes, we only got 3 coal. Which is, you know, that's roughly what you'd expect. 16 lots of recipes, 25% chance of coal. Yeah, that's sort of what you'd expect. And glowstone here, we got 43, and of course the full 16. Let's just do that again to have a look at the glowstone, what was being produced with the glowstone. So that's 2, that's the minimum. That time we got 2 again. That time we got 4. That time we got 3. That time we got 3, etc, etc. So you get the idea. So that's basically how the chance item stacks work. They work by just putting the extra information all in line in the recipe. Okay, so that was fun. Okay, next is fluid chance outputs. So fluid chance outputs are a little bit more confusing. Not too much more, but there's an extra little bit to it. Now, obviously, the whole idea of doing coin flips with fluids is a little bit different because fluids usually come in very large stacks. In other words, usually fluid recipes involve stacks of like 1,000 millibuckets of fluid. And of course, doing like 1,000 coin flips and getting like different horrible numbers, units of fluids out of your recipes is going to be absolutely disgusting. So basically the way this works is, as you can see here, it says here, for chance fluid stacks, a stack difference must also be specified. So what the stack difference is it tells you about how big the jumps are between the possible outputs from the chance fluid output. So for example, if I have a stack difference of 100, then what that means is that the different possible outputs of that recipe for that particular fluid will differ by 100 millibuckets. So if it's somewhere between 100 millibuckets and 500 millibuckets, then the possible outputs will be 100, 200, 300, 400, 500. And in that case, there'll be 5 coin flips. And obviously the chance of success is exactly the same as before, defined by this chance variable here. So you can either do just a percentage and a stack difference, and in that case, you will have a minimum of 0, like before. So for example, this liquid water ingredient has a 35% coin flip chance and a stack difference of 300. And because there's no minimum specified, the minimum is 0. So the possible outputs of this recipe are 0 millibuckets, 300, 600, 900, 1200, and 1500. So that means there's going to be 5 coin flips, okay, because 1500 divided by 300 is 5. So there's going to be 5 coin flips, each with a 35% chance of success. So a lot of the time you'll be getting sort of 600, 900. That's probably where the most probable outputs are going to be. But occasionally, if you're very lucky, you'll get 1500. And then here what we can see is we've got an oil output here of a maximum of 1000 millibuckets and a minimum of 400. And then the stack difference is 200. So the possible outputs are 400, 600, 800, and 1000. Now the difference here is 1000 minus 400, which is 600 millibuckets difference between the minimum and the maximum. The stack difference is 200, which means there's going to be 3 coin flips, each with an 80% success rate. So a lot of the time you're going to be getting around 800 millibuckets. So let's actually use these two things in a recipe. Let's have a look if we can do that in one of these recipes where we have fluid to fluid. Let's do a electrolyzer recipe because we have 4 fluid outputs there. So let's get that. Let's forget about all this optional stuff on the end. Okay, so fluid input, let's just do a standard input. Let's just do liquid lava, and you have to put 1000 millibuckets of lava in. Okay, so our first fluid output is going to be this first example of a chance fluid output. So this is going to be water. So that's going to be that 1500 water, 300 stack difference with 35% coin flip chance. So let's get that, put that in there. Then let's get the next one, which is this oil, which is a 200 millibucket stack difference, 80% coin flip. Put that in there, and because I'm really lazy, I'm just going to copy this over again. Okay, so they're going to go in there. Okay, so those are our outputs. Right, so after being confused for a few minutes, I found out that the fluid chance inputs aren't working exactly right at the moment. There's 2 things wrong with them. At the moment, the CraftTweaker recipe reading isn't quite working properly for when there's more than one chance liquid output. That was an easy fix. That literally took like 2 seconds. The bigger problem is that although you can actually add recipes which involve only one fluid chance stack, so here I've got a super cooler recipe. It's the water one, so max of 1500, stack difference of 300, so anywhere between 0 and 1500, but in steps of 300, so 0, 300, 600, etc. Another thing is that when it actually works out exactly how much to produce, I haven't actually taken the stack difference into account, so you're going to get horrible values at the moment. But that, again, should be an easy thing to fix. I'll get that sorted after this video. But if we have a look at the use of the recipes, in JI actually shows it correctly. This is what you should get when you put the lava in. So you can see here that you're getting jumps of 300 from 0, 300, 600, etc., all the way up to a maximum of 1,500. So that's what you should get when you put lava in. But at the moment, I'll just demonstrate. It's not quite working correctly, and if I put some lava in, you can see that time I got 505, that time I got 527 or something, and that time I got something else again. So at the moment, the numbers aren't quite working properly, but I'll get that sorted. That should be an easy fix, just a little bit of arithmetic, really. So I'll get that sorted for 2.11h, I guess it would be. Okay, so yeah, that's pretty much all there is to do with inputs. The final thing I should say, of course, is that you can make any of these inputs or outputs null. So if I wanted, instead of coal to be produced here, I'd get rid of this coal information. I just put null. That just means that there will be an empty output there. Of course, I can also put, for this isotope separator, I can also just put null for an ore output. I can put null pretty much anywhere. And null just means either an empty fluid stack or an empty item stack. Simple as that. So that's adding recipes. That's pretty much how it works. All of that works pretty fine, except for the, as I said, the chance fluid outputs. But otherwise it works well. The next thing to look at is recipe removal. So all you need to do for recipe removal, it's pretty simple. You just need to specify whether you're going to remove the recipe with an input or remove the recipe using an output. And you don't need to worry about any of the extras on the recipe. You don't have to worry about the power multiplier or the radiation or whatever. You don't have to worry about the chance. You just have to make sure that you all that data's not required. You just need to specify the ingredients. So let's do an example. Let's actually look at what sort of recipes we actually have in here. So let's look at the manufacturing. What recipes we got here? Well, diamond to diamond dust. Well, we can remove that recipe because it's pretty simple. And what other recipes do we have? We could remove this coal to crushed coal recipe as well. So let's remove the coal recipe via an input, and let's remove the crushed diamond recipe using an output. So what we want to do is we want to head into here, and we want to get this remove recipe with input. So let's go down here and remove the recipe with input, and the input is going to be Minecraft coal. Now I can either use Minecraft coal, or I could use the ore coal. So as coal is in the ore dictionary here as coal, I can actually just remove it with ore coal or Minecraft coal. It doesn't matter. It should work it out. So there we go. That's one way of doing it. And of course I can also go over here and remove recipes with output. This time I'm going to remove the output for diamond dust. So I'm going to use the ore here, which would be dust diamond. And again, I could use the actual ID of this diamond, crushed diamond. It would be NuclearCraft gem dust with metadata 0, but I'm just going to use the ore dictionary version. So if I save that and I restart my client, and hopefully if we head into the manufacturing recipes, we should see that the coal recipe is gone and the diamond recipe is gone. So the removal works there. I won't go through the fluids. The fluid works exactly the same way. If I wanted to remove, so if we go back into the supercooler, there's a recipe here for helium to liquid helium. You could just remove the helium recipe, via the input. So your input would just be liquid. It would just be helium times 8,000, and if you're going to remove it via output, it would be liquid helium times 25, for example. And of course, you can do the same with pretty much any of the machines. It works fine. Now, I haven't actually touched on the fission reactor and fusion reactor actually in the game as I actually initially planned. I actually don't think there's much need to. The recipe addition works in pretty much exactly the same way. The only difference with the fusion and the fission reactor, and later on the molten salt and all that stuff, is if we head into the CraftTweaker sort of templates and we go down to fission, and this is also the true for decay hastener. There's just some extra sort of stuff that you need to add onto the end, and these are not optional. You actually really need to specify this because obviously it, things like the power and heat of the fuel actually determines how it works. So you have the input and output as you would expect in a normal recipe, but then you have the base time of the fuel. That's in ticks, so that's a double. The base power in RF per tick, that's a double. Base heat in heat per tick, that's a double. The GUI name, which is sort of the name that appears in the bottom left down here, that name down there, you specify in the recipe. And then optional, this actually is optional if you want some radiation to be generated by the reaction, then you can put that in there. And for fusion, it's similar, input 1 and input 2, and then the 4 outputs, and then your combo process time in ticks, your base time, of course, bigger reactors will use it up quicker as anyway, but this is for a size 1, your combo power, your base power, and then your heat variable, which determines how the efficiency curve changes. Go and have a look at the fusion tutorial for more info about that, and the radiation if you want an optional bit of radiation. But the removal works in exactly the same way. You just need to specify the actual the ingredients involved. You don't have to worry about any of these extras. You can of course look at all the other stuff. This is some planned stuff down here, condenser and all this stuff. All the recipe addition works exactly the same way. So that is pretty much everything I can think of. and I think at that point we're good to finish this video. So thank you very much for watching. We've covered recipe addition, recipe removal. That's pretty much all there is to it. And hopefully it works fine. Obviously I'll get that chance fluid stuff fixed for the next version. Otherwise it all works as intended. So thank you all very much for watching. Any questions, of course, head down into the comments, and I will see you in the next video.